As we show you the equipment that's required, let's go over a few things with atmospheric monitoring. During our permitted process, if you have your permit on you, you'll see that there's places marked for you to make entries for atmospheric monitor readings. Now, nowhere in the law does it state where to, how often to do those readings, whether it's 5 or 15. The supervisor and the attendant can pick that out. And actually, it's dependent on the situation as well. If you have a very hazardous environment, probably do it every so often. But just know that someone has to take responsibility for doing that atmospheric monitoring. So when we talk about resources, that's for us, for San Diego, we like having the hazmat team because then they can concentrate on their number one thing, which would be hazardous atmosphere monitoring. And when they would do it constantly, it would be constant. What I did want to show you is you have probably already seen the rescuer that will be wearing that independent device. But we also have this device. Okay, so it is basically the same monitor, but it has a hose. And the hose is able to let us extend out. Now, hazmat has hoses that can run up to 10 to 15 to sometimes 30 feet. The longer the hose, the longer it takes to get a reading on there. But let's go ahead and let's review these monitors. Now, typically in a confined space environment, we'll have atmospheric monitoring from the top side or outside the hole or on the approach to the entry space. But also we have personal monitoring. And personal monitoring is happening constantly. Just know that on the communication devices that we have, the CONCOM that you might have already seen, which is intrinsically safe, it's also an open communication system. What's that mean? Well, the rescuer doesn't have to push any buttons, nor does the outside attendant have to push any buttons. It's open communication, speak freely, you have good two-way communication that's constant. So what would the attendant be telling the entrant? Hey, you know, as an entrant, I have a lot on my mind, so I'm going to forget to do any type of monitoring. So what you may do is an attendant may say, hey, Mike, I know you're 50 feet into your entry. Hey, real quick, it's been a long time since we did an atmospheric monitor check. At that point, you would get the monitor reading from the entrant. Hopefully, it's not alarming. What does an alarm sound like? An alarm sounds like that. So this thing will vibrate. You'll hear the lights go on and off, and you'll hear some noises coming out of this. So that's what an alarm sounds like. And there's the lights. And that's me turning it off. So this is the alarm. Again, just to review, typical fire service monitors read for oxygen. We're looking for 19.5 to 23.5. H2S, typically for these, it's 10 parts per million. Carbon monoxide, typically 25 parts per million or 35 parts per million. And then for the explosive meter, it looks for flammability, and that would be looking at 10% of the lower explosive limit of whatever's in there. So it reads those four things. Beyond that, we would need other meters as well. So there are limitations, but this is important to use. Now remember, if we monitor the environment, atmosphere stratifies, toxicity stratifies, carbon monoxide stratifies, H2S stratifies, so we want to read all levels of that entry. Now, most of the time I've been talking about these spaces as far as vertical entries. Just know that confined space entries can also be horizontal. So we'll talk about that as well as we get into the retrieval devices with rope and systems operating. So that's it on confined space monitoring. These are typical fire service devices. This is called the MSA Alt-Air. And so as far as atmospheric monitoring, that's what will be accomplished. Now, when do we want that done? We want atmospheric monitoring done right away on arrival and constantly throughout the operation. Another operation for hazardous atmospheres that we would do as well is we could use ventilation. Now we've monitored the area, remember we have to have quite a few air exchanges, a minimum to 5 to 8 air exchanges of a space. So if we arrive on scene and ventilation is available, that's one of the first things we want to start doing. This particular ventilation fan says that it has straight free air, meaning there's no kinks in the lines that we're using. It'll provide us 980 cubic feet per minute. So if we have a 1,000 square foot space, or excuse me, 1,000 cubic foot space, it'll take approximately 1 minute to clear that. So what does that mean? It takes about 5 to 8 minutes to do 5 to 8 air exchanges. So typically the people that we're waiting for as far as the entry is the entrant to get all suited up. So we pretty much have some time. Professional rescue teams can get ready fairly quickly, probably upon arrival, probably 5 to 10 minutes. But in my experience, typically it takes roughly about 20 minutes for everything to come together and to make an entry. Obviously, that's a sliding scale as far as speed, depending on the risk versus benefit and the survivability of the patient. So the more people you have, the quicker the operation goes. The more skilled people you have, the more simpler, the more quickly, and the more proficiently the operation goes. So it definitely depends. These incidents depends on skilled personnel. So number one, again, to review, hazmat team is a good option, a technical rescue team, and many people at scene. A lot of resources, personnel to help handle the incident. Let's look further at this, this ventilation fan. So the ventilation fan comes like this, comes into 2 pieces. And what will happen, I'll put my permit aside here that's sitting at the portal of my entry. Okay, confined space permit should be at the portal of an entry. Put that aside here. And what happens is this thing, it's also intrinsically safe. What I can do is I unclip this here. It comes as one piece. It comes apart. And this is my fan. Okay, so this is the intake of my fan, or I'm sorry, this is the output. It has an arrow, intake, output. Has a corded line. This corded line is intrinsically safe. If I needed to drop I'll cut this power to power. And inside this casing here, if I unsnap this, it's the hose. All right. So I don't want to be too close to the hole, right? Because I want to get fresh air. So what I can do is I could place my fan, and I'll place it way out here. And I'll stick this hose into the space. Just imagine that the space is vertical, and we could take all this hose and dip it down into the space, and it would go inside there. And this end would connect up, back up to the way it was packaged. It would connect to the output of the fan. So atmospheric monitoring, ventilation, that's one way to monitor the environment, to either using ventilation for intake or exhausting of the material. And remember, where that hose sits needs to be taken into account the stratification of the layers. And then the other way we also protect ourselves, number one, we're going to eliminate the risk, reduce the hazard, and further protect ourselves using full SCBA or full-faced air purifying respirator.